There are two building blocks in this course. This is the first one, a fixed coupon bond. Okay? So a fixed coupon bond, as the name suggests, is a bond that pays a known, predetermined, fixed coupon at regular dates. So it's like that bond we saw in the very beginning of the course, right? So how do we compute the price? Well, it's very easy because the coupons are determined, they are fixed. So the price of the bond is just the present value of future cash flows. So that's this equation that you have here. We're going to usually use a B for the price of a coupon bond. And what we're saying is that the price on the left is equal to the present value of future cash flows. What are the future cash flows? Are the coupons that we are denoting here by C, which will have some compounding frequency denoted by N. So if, for example, if the coupons are paid twice per year, semi-annually, the N would be 2. And there will be a stream of these coupons. And we are going to discount all these coupons from the dates and when they are paid back to today using the discount factor. We denote the discount factor either by Z, as we did before, or by P, as you see here. Okay, so these are discount factors, just like we defined them before. And then at the end, there is a final payment of face value, 100%, or 1, which is not shown here, but it's 1 times the discount factor for the last date, the maturity date, right? So we can use either discount factors or interest rates, as we have seen before, and this would be the formulas with the corresponding interest rates. Let's do an example. Just a detail before this. In the US market, treasury notes and bonds always pay semi-annual coupons. So when you're doing exercises in the book, in the Veronese book, if they say that compute the price of this treasury bond that pays a 5% coupon. Even without saying anything else, you always have to assume that those 5% coupons would be paid in 2 installments per year, so semi-annual compounding. Okay, so it's always semi-annual compounding for those US treasury notes and bonds. Okay, so example. So let's say that we have these interest rates today with semi-annual compounding from 3 months, 6 months, 9 months, 1 year. Okay, these numbers here. And now I want to price a new bond. Okay, let's a different bond. Let's say it's a 5% treasury bond. So this 5% again, it's the coupon rate. It's always stated as an annual figure. But since this is a treasury bond, as I just said, we always assume semi-annual payments. So I will get 5% divided by 2 every 6 months. And the maturity is 9 months from now. Okay? And I want to find the price. So let's look at the timeline. Okay. So here people sometimes get a little bit confused with this, so let's do this once carefully. I am here at time 0 and I want to find the price of the bond today. Okay, this is my unknown. What I know is that maturity is 9 months from now, and it's always the case that at maturity I get face value and the last coupon. The coupons are semi-annual, so 5% divided by 2. The point where sometimes people get confused is when is the next coupon? Right? And note that the coupons are always defined backwards, from the maturity backwards. So if these are semi-annual coupons and the maturity is 9 months from now, I go back 6 months and that's when the next coupon will be. So okay, the next coupon will be 3 months from today. Okay? And the amount is 5% divided by 2. Right, so now it's easy, right? The cash flows are defined, well known, 5% divided by 2, and here 102.5%. So these two cash flows, this one and this one. And now I just have to go look in that table I had the interest rates and pick the interest rates corresponding to these two dates, 3 and 9 months. Okay. So if I look at that table that is in the handouts, the 3-month rate is 3%. It has semi-annual compounding, so I have to discount it like this, divide the 3 by 2 and then raise to 2 times this distance here, which is 0.25. And then for 9 months, the rate in the table is 4%, again with semi-annual compounding, so divide by 2 and then raise to 2 times the distance between here and here, which is 0.75 years. And that will give me this bond price that you see here. All right. A corresponding concept is the yield to maturity. So what is the yield to maturity? First, the yield to maturity is just an alternative way of representing the bond price, meaning that if I know one, I always know the other. If I know the price, I always know the yield to maturity, and if I know the yield to maturity, I always know the price. Okay, so it is just an alternative way of representing the same reality, which is the bond price. And we find it sometimes more intuitive to talk about interest rates than bond prices. So it's more meaningful to talk about yield to maturity than a bond price. Okay, so how do I compute exactly the yield to maturity? Well, I am going to do the same calculation I did in the previous example, but in the other direction. Meaning, instead of finding the bond price, what I'm going to do now is I'm going to take the market price of the bond as given. So this left-hand side now is what I know. I always know the coupons, so the numerators are always defined. But what I do not know, what I'm going to find out with this equation, is the yield to maturity, the interest rate. So it's a constant interest rate, a constant number here. It does not change with maturity, it's always the same number. But it is that single number that satisfies this equation, that forces the cash flows to add up to the bond price. Okay, the discount rate that discounts the cash flow such that they add up to the bond price. Okay, this is something that we cannot do by hand when we have bonds with several coupons. So we have to do this with the computer. Okay, so an example. I encourage you to do this at home. So this is actually pretty simple. You just have, it's the same bond as before, so you just have two periods. The price is given. So try to solve for the constant discount rate that satisfies this equation, okay? So that matches the bond price. And this is what I get. An annual rate of 4.0338%, right? So again, please try to do this at home. We will soon have a project where you'll have to do this for many bonds. So this is an easy warm-up to set up the Excel file or whatever you use to do this to make sure you are able to get the yield to maturity. Okay. Interpretation. So what is the yield to maturity? So again, this is just the other side of the same coin. If we know the price, we know the yield, and vice versa. But it's an interesting concept because it is more meaningful, more easy to understand. However, there are some details that are not immediately obvious. So if I say that the interest rate on a bond is 4%, I interpret that as the rate that I will make if I invest in that bond. But that is only true in some conditions. So if the yield to maturity is, say, 4%, I will only get to the end of the investment and make exactly 4% if two things hold, if these two conditions are met. Well, the first one is kind of obvious because it's in the name. This is called yield to maturity, meaning that I am going to get 4% if I hold the bond until maturity. Okay, so that's the first condition. It's kind of obvious. The second condition is not so obvious, meaning the calculation of the yield to maturity implicitly assumes that I will reinvest the coupons, the intermediate coupons, in the future at that same rate that I'm computing. So in this example, I will only really get 4% in the end if during the life of the bond I reinvest the intermediate coupons at that same 4%. And this one is an assumption that is not under my control because I have no idea of knowing, I have no way of guaranteeing the rate at which I will reinvest the coupons in the future. Okay. There is another detail in this yield to maturity, which again is not so obvious, and it's think of this like a disadvantage of the yield to maturity, which is the yield to maturity depends on something that it should not depend. So it depends on the coupon rate itself. So for example, suppose now that you have an 8% treasury bond that is exactly like the one you saw before. The only difference here is the coupon rate, okay? It's the same maturity date, but the same coupon frequency, but the rate, instead of the 5% we had before, now it's 8%. So we are going to compute the price of this bond using exactly the same discount rates as we did in that example and find this bond price, 104.93. So the market, the underlying market is the same, is using the same discount rates, okay? We get the price of this bond. And now I'm going to compute the yield to maturity on this bond. So take this market price as given, take the coupons, the numerators as given, and solve for the constant yield to maturity. And if you do this calculation, you will find a number that is slightly different from the yield to maturity of the previous example. So what you have here, it's a bond that is being priced with exactly the same discount rates, that has exactly the same maturity, but it gives you a different yield to maturity, just because the coupon rate is different, okay? So this is a defect, if you will, a disadvantage of the yield to maturity. But again, going back, the purpose of the yield to maturity is to give us a simple information that is more easy to understand, more intuitive than bond prices in some cases. Okay, stop here.